These are notes for AP Calculus AB. This is 8.4. And on this objective, we'll be integrating the 6 trig functions. We've done a lot at this point with the trig functions. We've done the derivative of all 6 trig functions, and we've done integrating with trig functions. So I'm going to remind you of a few things that we already know, starting with the derivative of sine x is cosine x. And we know the derivative of cosine is negative sine. The derivative of tangent is secant squared. The derivative of secant is secant times tangent, and so on. So we also learned how to integrate. If I have any of these values over here on the right, I can integrate back to the original functions. So we did all of this when we learned integration in our Unit 5. So we could integrate cosine, you get back to sine. If I integrate secant squared, we get back to tangent. If we integrate secant times tangent, we get back to secant, and every time, of course, adding c. So we've done those. We've done the derivative of all 6. We've integrated back to all 6. What we're doing today is making sure we know how to integrate all 6. So can we integrate sine, integrate cosine? Yes, because we've already done those. So what we also want to do today is be able to integrate tangent, cotangent, secant, and cosecant. So what we're going to do first is figure out what the formula is for integrating tangent. All right, so in order to do this, we're going to use our first formulas that we already know. Actually, we're going to use the second one, which is integrating 1 over u. So what I'll do is rewrite tangent as a fraction. We're going to write it as sine over cosine. So now I can throw in some substitution. We're going to let u equal cosine x. The derivative of cosine is negative sine, and we multiply over by dx. There is no negative in front of sine, so negative du will replace sine x dx, and now we'll make that substitution in. So my integral becomes u replacing cosine, and sine x dx will be replaced by a negative, so I'll go ahead and make it a negative 1 du. Now the negative is just a coefficient, so when I integrate, I'll get a negative. I'm left with integrating 1 over u, which integrates back to the natural log of the absolute value of u plus c. So I substitute back in for u cosine. This is negative natural log times the absolute value, negative natural log of the absolute value of cosine x plus c. And you'll need your absolute value symbols because the trig functions have both positive and negative values. Now, this means that the integral of tangent is negative natural log of the absolute value of cosine x plus c. That's not a very pretty formula for us to work with because we usually associate tangent with things with secant. Notice the derivative of tangent is secant squared. Secant's derivative is secant times tangent. Even in our Pythagorean identities, tangent squared plus 1 is secant squared. So what we're going to do is use our log property. We're going to replace that negative coefficient as the exponent. So cosine to the power negative 1 becomes 1 over cosine. And 1 over cosine is secant. So there we have the formula that we'll want to use. So formula number 3, the integral of tangent u du, in case there is some kind of substitution going on, gives us the natural log of the absolute value of secant u plus c. And so that is the actual formula that we'll want to use. The other formulas are found the same way. So instead of having to derive all of them, I'm just going to give you the remaining ones. So that's the integral for tangent, the integral for cotangent. So just like derivative of anything that starts with a c, the integral of cotangent is going to start with a negative natural log of the absolute value of cosecant u plus c. So tangent with secant, cotangent with cosecant, positive, negative. So we just want to be able to remember these quickly. So we'll look for things that are similar. So the next one, we want to be able to integrate secant and cosecant as well. So the integral of secant u. So again, we associate secant with tangent. Remember, the derivative of secant is secant times tangent. When you integrate secant, you end up with the natural log of the absolute value of secant u plus tangent u plus c. So that's a little bit different. The derivative has a product. The integral has an addition sign. All right, one more. So going by the patterns that we have here, if we're writing out the formula for integrating cosecant, starts with a c, so it should be negative. At that point, though, it should follow more closely to the integral of secant. So secant, secant tangent, cosecant, cosecant plus cotangent plus c. So very similar to the derivative of cosecant, except we have the addition. And of course, they all have this natural log going on. And that is why we didn't learn them until now, because we hadn't done the integral of 1 over u until now. So all the problems in this section will either be a review from Objective 3, so you're getting more practice with that, or you'll have practice with these integrals here with the trig. So just to do another example here. All right, so if we run into integrating cosecant 2x dx, so we'll let our u substitution take the place of the 2x so that it follows along like our formulas do. So u is equal to 2x. Our derivative then is 2 times dx. There is no coefficient 2 here, so we'll divide 2 over. And 1/2 du will replace the dx. So 1/2 du to replace dx. You're left with cosecant of u. I think a lot of people feel like when they're substituting with a trig integral that you should always be taking the place of the trig function. So that doesn't always happen. It sometimes happens. In this case, it's taking the place of what's inside because I can integrate cosecant. I have a formula for integrating it. We're going to keep that 1/2 coefficient. In integrating cosecant, we end up with a negative natural log. So I'm going to be really careful here. I either need room to throw that negative in front, or I need to show multiplication with parentheses. Negative natural log, absolute value of cosecant u plus cotangent u plus c. So in rewriting this, I'll go ahead and bring that negative out front with the 1/2. Natural log of the absolute value of cosecant 2x plus cotangent 2x plus c. So that would be an answer here in this problem. All right, so that's the end of the 8.4 notes.